Okay, so we're going to talk about this AP problem that you'll had a chance to look at. So it gives you the x and y components of the velocity and an initial position. And so standard question that they like to ask, where is the tangent line vertical? And of course, tangent line is vertical when the slope is undefined. Slope is dy dt over dx dt. And so the slope will be 0 when dx dt, or the slope will be undefined. Tangent line will be vertical when this dx dt equals 0. And of course, this is a calculator OK question. We see trig functions here. We sort of realize this probably has infinitely many answers. We're only interested in the times between 0 and 1.5, and so we're going to probably do it graphically. We also technically have to make sure that y prime is not also 0 at the same time, because then you get something that's undefined or indeterminate. And so we see these two answers from our calculator. So just sorry if that was too fast. 1.253 and 1.144 are the two answers, or 1.145, always accurate to 3 decimal places, of course. Write the equation of the line tangent to the path of the particle at t equals 1. So we need to know where it is at time 1, which ends up being the trickier part, and what the slope is at time 1. And so to find the slope at time 1, we plug 1 into y prime and 1 into x prime and divide them. So dy dt over dx dt. They had given us the position at time 0. And so you have to integrate the x velocity from 0 to 1, which gives you the x displacement. Add that to where the x coordinate started. That gives you the x coordinate where you ended up. And then integrate the y velocity from 0 to 1. That tells you the y displacement. Add that to where the y started, and we've got the y coordinate. And then we just go slope-intercept form and write the equation. Notice 4 points here, so quite a bit. 1 point for having the slope correct, 1 point for finding the x and y position, and then 1 point for writing the equation correctly in the end. Question C, find the speed of the particle at time 1. That's simply the length of the velocity vector at time 1. And so we had found x prime 1 and y prime of 1 in the previous problem. We just plug it in, do the Pythagorean theorem on your calculator. You have to be careful how you type that in. There's a fair bit going on there. And accurate to 3 decimal places. Keep in mind probably a common mistake here, right? Remember, they gave you the velocity things already, and so you're not taking, up to this point, we have not taken the derivatives of these things that they gave us. But now, finally, in question D, it says find the acceleration vector, so x and y components, at t equals 1. So not the general formulas, but t equals 1, and that makes it nice because if we need to evaluate a derivative at a specific point, we should use Math 8 and deriv to speed things along. So n deriv for this one, n deriv for this one, evaluated at 1, and you write it as a vector, accurate to 3 decimal points, 2 points, 1 for each of those numbers, negative 28.425 and 2.161. Hopefully that one went well for you. It's basically a pretty standard parametric AP problem.